Hello, I'm Single-Minded Ryan. In this video, I'm going to show you 5 essential effects for 2D top-down Godot games. The first one is this glow effect. The second one is the wind shader effect for the trees. The third one is the white sword effect. The fourth is the damage number effect. And the last one is the 2D light and shadow. Alright, let's get started. If we just want a still image to glow, we can just use a mask to isolate the color that we want to glow. But here, we are working on an animation. I'm going to show you how to extract a color to make a mask. Once you understand how to do it, you can make any color to glow for an animation. First, you need to set the render method to forward plus. Next, you need to enable HDR2D. Go to Project Settings, then select Viewport under Rendering. Now let's enable HDR2D, because the glow effect depends on the HDR value of the color. Next, to enable the glow effect, we need to add a world environment node to the root node of the scene. Let's create a new environment in the inspector. Then we can click on it again to expand it. Let's go to background and set mode to canvas. Now we can enable glow. Let's set blend mode to screen. I want you to pay attention to this HDR threshold, because any color with an HDR value that's higher than the threshold is going to glow. Let me show you how it works. I'm going to select the Animated Sprite 2D node of my player character. Then I can go to Visibility and change the modulate color. And let's increase the I value to around 2, and you can see the entire sprite starts to glow. Basically, this is how we make the entire sprite to glow. But in my case, I just want the glow effect when the player is swinging the sword. So I need to create a mask to isolate the color that I want to glow. And I'm going to do it in a visual shader. So let's go down to create a shader material. Then click on it again to create a new shader. Make sure the type is visual shader. Then let me show you the color that I want to glow. I'm going to select the attack animation to the left direction. And I want this highlight color around the sword to glow. This color only appears in a couple frames in the attack animation. Next, let's open the visual shader we just created. Let me just hide the things we don't need to make some room. You need to make sure you are in the fragment mode. Before we go ahead to work with this visual shader, I want to briefly mention that the project I'm using here is from my latest 2D top-down Godot course on Udemy. In the course, I'm going to show you how to create a 2D top-down Godot game from scratch with good-looking game assets. And I'm going to leave the discount link to the course in the description below in case you are interested. Alright, let's go back to the visual shader. First, let's add a color node. You can find the color node under Input, All. Basically, this node represents the sprite itself. Let's connect it to a color operator node. Let's set the mode to difference. Next, let's create a color parameter for the B input of the color operator. I'm going to name it to mask color and set the qualifier to instance. This is to make sure that when you have multiple characters using the same shader, each shader can have an individual value for the mask color property. Then let's connect it to the B input of the color operator. What we are doing here is that we compare the mask color to the color of the sprite, and we are going to get a black color as a result when the two colors are the same. Let's connect the color operator to the color property of the output. By the way, if the mask color parameter doesn't appear in the inspector, then you might need to deselect and reselect the Animated Sprite 2D node. Now we can see the parameter in the inspector. Let me set it to the highlight color that I want to glow. I'm just going to put in the hex code here, since I already know the hex code of the highlight color that I want. And you can see the area near the sword becomes black, because the color of this area matches the mask color I just put in. Alright, next we need to turn this black color into a mask. Let's connect the color operator to an if node. Let's set the color for the A equals B condition to white. Let's put 1 in all 3 channels so we get the white color. Then we connect the if node to the color property of the output. Nothing happens because we need to increase the tolerance. Let's create a float parameter for the tolerance. Set qualifier to instance, and let's set hint to range. Usually for tolerance, we just need a very small number. So let's set min to 0.001 and set max to 0.003. Now we can tweak this parameter until we see the white part of the mask. Good, we have successfully isolated the color we want. And let me also double check to make sure it works for all attack animations for different directions. Seems like everything works very well. So let's go back to the shader editor. We want to use the mask to change the color of the highlight area. Let's add a switch vector 3D node. Then connect the mask to the value input. Then we connect the color node, which is the original sprite, to the false input. For the true input, let's create a new color parameter. I'm going to call it glow color. Set qualifier to instance. Now we can connect the switch node to the color property of the output. Let's set the new glow color property to the same color as we used for the mask color. Then we just need to increase the I value of this color to make it glow. I'll just set the I value to a number around 2. And we should be able to see the glow effect. If I go to the third frame of the attack animation, alright, we get the glow effect. We can select the world environment node to tweak the settings. Alright, now let's test the game. Please check out my new course on Udemy from the link in the description below. In this video, I'm going to show you how to create this wind shader effect, and it's very useful for the trees in a 2D top-down game. I'm going to show you how to randomize the rate of the sway for each individual tree. First, let's create a new visual shader for the Sprite 2D node of the tree. Then open the shader editor. Let me hide the things that we don't need to make more room. I want to briefly mention that the project I'm using here is from my latest 2D top-down Godot course. For the full course, please check out the link in the description below. Make sure we are in the vertex mode and add a UV node. We are going to use the green channel of the UV as the mask of the swaying movement. Let's remap the value of the green channel. This is going to reverse the mask upside down. Also leave the bottom area black, so the stump of the tree is not going to be affected. Next, let's multiply the mask by a float value. This value is going to decide the direction and the range of the swaying movement. To actually change the look of the sprite, we need to update its vertex. So let's add a vertex node. We only want to change the horizontal value of the vertices. So let's decompose the vertex node into a vector 2. Then let's multiply the x value by the value of the swaying movement. Now let's compose the values back into a vector 2. Alright, now we can connect the final value to the vertex property of the shader. Now we can change the float value to check out the result. Next, let's find out a way to update this value to create a loop animation. We can do it using the time node. Let's multiply the time by a float value, because the value of time passes really slowly, and we need it to change faster. To randomize the speed, let's create a float parameter. We are going to set this parameter in the script with a random number. So let's name it random strings. You need to set qualifier to instance. We need this value to bounce back and forth. So let's connect it to a sign node. So the float is always between -1 and 1. Then we plug in this value and we're done. And this is the final graph for your reference. Next, let's update the parameter in the script. You can ignore the existing code in this script, since it has nothing to do with this shader. And we just need to add one line in the ready function. This line is going to update the random strings parameter with a random float number at the beginning of the game. Alright, we are finished. Let's test the game. I'm going to show you how to use Y-sort for 2D top-down games. Y-sort is the feature that you must know if you're making a top-down game like what I am showing you here on screen. The player can come out in front of the bush and the tree if its Y position is lower than them. And the player can also get behind the bush and the tree if the Y position is higher. Alright, let me quickly draw a bush to show you how to use Y-sort. Now I have the bush in my project. Before we get started, I want to briefly mention that the project I'm using here is from my latest Godot course. I just released it on Udemy. The course is going to help you understand how to make a 2D top-down game with Godot from scratch. I'll link a discount coupon in the description below. Please consider to give it a try if you are interested. Alright, go back to the video. I'm going to drag the bush into the game scene. The bush node is in the bottom of the scene tree, so if we run the game to test, we are going to see the bush is on top of everything else. This is obviously not what we want. So let's fix it with a Y-sort feature. But we do not need to enable Y-sort in the bush node. Instead, we put all of the nodes we want to sort under a parent node. And we just need to enable Y-sort in the parent node. In my case, I have put most of the nodes under the level node. Let me select the level node. You'll see Y-sort is enabled under ordering. So we just need to drag the bush node into the level node. Now let's run the game to check out the difference. The player should be able to get behind this bush if the Y position is higher. It works, but we have a small issue. The player only gets behind when it's higher than the center point of the bush. This is because Y-sort is calculated based on the center point of the node. Let me show you how to fix it. I'm going to duplicate a new bush and move it to the right. Then I'm going to change the offset of the sprite. Let's decrease the Y value of offset, so the sprite is offset upward. And the center point of the node now locates near the bottom of the bush. Let's run the game to test again. Great, this is what we want. the player gets behind the bush at the right position, and we can compare to the previous one. Alright, now I hope you understand how Y-sort works in Godot. Let me just remove the previous bush node and add more bushes to the scene to test. Alright, I hope you enjoyed this video. And please check out my Godot course on Udemy from the link in the description. First, I'm going to add a label node to my enemy scene file. Rename the label node to damage label. Let's just put a placeholder number in the text field. Set horizontal alignment to center and vertical alignment to center too. Then go to transform under layout. I'm going to set the size of the label to 50 by 30. And we want the pivot point to be sitting at the center of the label. We can do that by setting the pivot offset to half of the size. Then let's make the size of the text smaller by decreasing the scale to 0.4. Notice that I do not decrease the font size of the text, because that is going to make the text blurry. Next, we want the label to be on top of everything else. So let's set the z-index to 100. Then I'm going to add a new script to the label. This script is going to animate the label so it looks like the damage number floats upward. But before we start writing the code, let's convert this damage label node into a scene file. Just drag the node into somewhere in the project folder. And we actually don't need it in the enemy scene, since we are going to instantiate the damage number every time the enemy gets hit. But before we delete the damage label, we need to find out the right position where we want to instantiate it. So let me just move the label to somewhere above the enemy. I think this place is great. And we can go to transform to check the position. The position is -25 and -70. This is the relative position to the center point of the enemy scene. And we need to take note of this position, since we need it in the code. Alright, now we can remove the damage label node. And let's switch to the new script we just created. Before we continue, I want to briefly mention that the project that I am using here is from a new Godot course on Udemy. The course is going to help you understand how to make a 2D top-down game with Godot from scratch. I'll link a discount coupon in the description below. Please consider to give it a try if you are interested. Alright, go back to the video. First, we want to animate the label, and we can do it in the built-in _ready function. In the function, let me create a tween for the animations. First, I want to make the damage number bigger. Then I want it to move upward. Then I want it to become smaller until the size becomes 0. I'm going to divide all of these into 3 animations. Let's set the tween to parallel, so all of the animations start at the same time. This is going to help us manage the timing of the animations easier. For the first animation, let's call the tween property function on the tween, and we want to change the scale property. The target value is 0.7 and 0.7, and the duration is 0.2 seconds. So this animation happens really fast. For the next animation, we also want to animate the scale property. This time, the target value is vector2.0, and the duration is 0.5 seconds. But we want this to happen after the first animation. So let's set the delay to 0.4 seconds. For the last animation, we want to change the Y value of the position, and we want the damage number to move upward by 80 pixels. And the duration of the animation is 2 seconds. Let's also set the delay to 0.4 seconds, so this animation starts at the same time with the second one. The last thing is to remove the damage number from the scene after all the animations are finished. And that's it for this script. Next, we need to instantiate the damage number whenever the enemy is attacked. The code that damages the enemy is in my base character script, so let's go to this script. You can ignore all of the code in this script since it has nothing to do with this video. Just focus on the code I'm about to write. First, we want the damage label scene file. Let's hold the Control key and drag it into the script. Then let's go to the getHit function. And let's add some code under the line that damages the enemy. In fact, this script is also used by my player, so we'll also see the damage number on the player when the player is attacked by the enemy. Go back to the script. Let's first initiate a new damage number using the scene file. I'm going to store the result in a variable called newDamageLabel. Notice that I cast the newDamageLabel into a label node. This way we can update its text property. So let me just set the text property to the damage that the enemy just received. Next, we need to update the position of the newDamageLabel to the position of the enemy. And we also don't want to miss the offset value. This way, the number is going to appear on top of the enemy. Then we need to add the newDamageLabel into the current game scene. Notice that I don't want the number to move with the enemy, so I just add the newDamageLabel to the rule node of the scene. Alright, we have finished, and this is the final result. I hope you've learned something new, and please check out my new Godot course on Udemy. First, let's add a point light 2D node to the player node. Then let's create a gradient texture 2D. Set the fill property to radial. Now we can tweak the black and white colors to create a mask for the light. Let's increase the size to 512 by 512. Increase the energy to 6. Let's tweak the colors a little bit more to make the mask as soft as possible. Now we can enable shadow. Next, I'll select the tilemap layer node of the wall and add a new occlusion layer. Go to the tileset panel, select paint, and select the new occlusion layer we just added. Now I'll just paint all of the tiles so they can block the light and cast the shadow. Alright, now we can see the shadow. But we have a problem here. The light also brightens everything in the game. And the player can get into the shadow when it's close to the wall. This is not what I want. Before we continue, I want to briefly mention that the project I'm using here is from my latest Godot course. I just released it on Udemy. The course is going to help you understand how to make a 2D top-down game with Godot from scratch. I'll link a discount coupon in the description below. Please consider to give it a try if you are interested. Alright, go back to the video. Let's go to the player scene and select the Animated by 2D node. We can exclude this node from the light. Also, I want to exclude the shadow sprite from the light. Next, let's go back to the main scene and add a world environment node. Create a new environment. Set mode under background to canvas. Then let's set the tone map to ACES. Let's also darken the background and the wall. One last thing, if you want the shadow to look soft, you can change the filter of the shadow to PCF13. That's it for this video. I hope you've learned something new. And please check out my new Godot course on Udemy. Thanks, and see you next time.